This is Josh White with JW Math Tutoring. In today's video, I'm going to go over 10 problems from the October 2025 Digital SAT Math Test. So let's go ahead and take a look.
But life is a dream that calculus could never predict.
Before I begin going through these 10 problems on this October 2025 SAT official test problem worksheet number 2, please keep the following things in mind. First, of course, if you like this video, please give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, there'll be a link to the PDF file that has all these problems in it in both the description of the video and in the pinned comment below the video. Third, these are all self-reported questions, so I've tried to gather as much information as possible and reconstruct them to make them as realistic as possible. But there could be minor or even possibly major differences between the problems you see here and one you may have had on test day. So that could include a problem being multiple choice when you took it on an exam versus here being free response. So there could be other solution methods to solve it if it's multiple choice, or there could be other details, that I don't have in the problem here that maybe you remember from when you saw this problem on your test. Okay, so just keep that in mind. And then lastly, going forward, basically there's going to be video worksheet number 1, which hopefully you've already watched, and then this video worksheet number 2, which those two will be comprised of basically new problems, maybe problems that have been covered like once before, but not more than that. And then I'm going to have a separate video. It'll basically be video worksheet number 3, which will go through all of the review problems, like some of the ones that I've already covered, 2 or 3 or even 4 times in previous videos. And I'll mention what the problems are. I'll show you exactly what videos and what worksheets to find them on, so that if you had those questions, you can go watch those videos and review them. But there's no reason to go through, the same problem 4, 5, 6, 7 different times when, it's already been done. Okay, so with all that being said, let's go ahead and get started here. October 2025, Digital SAT Math Official Test, Worksheet number 2. Question 1. You have this quadratic function. They give you the vertex. They also give you another point on the function. And they tell you that there's a new function that you make by multiplying the y-coordinate of each point from the original function g of x by 6. Okay, what is the difference in the y-intercepts of the two functions? Okay, so vertex form of a quadratic function looks like this. Okay, keep in mind this a is not the same as this a right here. All right. All right, so I'm going to take the point, plug that in for x and y. I'm going to plug in 5 for h, negative 10 for k. Now, this equation, you could go ahead and you could solve it out by hand, but there's no reason really to do that. So I am just going to go to Desmos and just use regression to figure out what the value of a is for the original quadratic g of x. All right, and it's negative 2. So that means g of x is equal to negative 2 parentheses x minus 5 squared minus 10. Now, h of x is basically like 6 times this. So you're doing 6 and then times the entire thing. Okay, negative 2 x minus 5 squared minus 10. Okay, now you have to find the y-intercepts of both graphs and then subtract them. So really the y-intercept is just plugging 0 in here, plugging 0 in here. And again, you could do all this work by hand, but there's no reason to. Like, I'm just going to go to Desmos. Let's graph out both the files and just get the y-intercept values right from there. Okay, so the first one, g of x. We've got negative 2, x minus 5. Again, you could plug 0 in here and do the calculation in Desmos. That would be fine. Let's do h of x. Now it's... And I can just do it like this. I can just do 6 times g of x. I don't need to type out the whole, whole long thing, right? Okay, so now if we want to get it from the graph, okay, well, we got to zoom out here. Where are these? Okay, so one of them is right here. The other one, where does the green one cross? Oh, there it is down here. Okay. So A corresponds to g of x, which is the blue. Okay. So now this is my A value, and B corresponds to the y-intercept for the green. Okay, so I want to know A minus B. There it is, 300, and that's our answer. Notice an alternate way to do this. You could also recognize that to get the y-intercept, you just do like g of 0 and h of 0. So you could technically do like just g of 0 minus h of 0 and just get it that way. That's probably quicker and easier than hunting, on the graphs. Now, here's also how you could use Desmos to even shorten some of this work as well. Okay, so you can use regression, and you would put the given point into your table. Then you would do regression in vertex form. You have to know that the 5 goes in here, and the -10 goes in here. Okay, here is the original function. So now at this point, what I would probably do is I would say, okay, g of x equals -2 times x minus 5 squared minus 10. And then you could do h of x equals 6 times g of x, because every y-coordinate point is multiplied by 6. So now you could either go to the graphs, like I just did, or again, you could just do g of 0 minus h of 0 and get your answer that way. All right, looking at the next question, number 2. This one actually is a tricky question because you have, these lines and you have multiple letters. Now they tell you k and t are constants. They want to know how many times do these lines intersect. So here's the thing. If k is a constant, meaning a number, not a variable, and y is a constant, meaning a number, not a variable, then this first one is just a horizontal line, just x equals a number. And the second one is just a vertical line, y equals a number. So how many times will a horizontal and vertical line intersect? Well, just once, because they're perpendicular to each other. So the correct answer is letter B, and we can just confirm that in Desmos. So let's go here and let's graph out, okay, x plus k equals 6. Y plus t equals 2. All right? K is going to equal whatever, 2. T is going to equal 7. Okay, so let's zoom out. All right, here are my two lines. How many times do they intersect? Well, right here at this one singular point. And notice, if I move the slider, there's still one intersection. Notice, I move the slider, there's still only one intersection, and there should always be one intersection. So correct answer for this is letter B. All right, let's look now at question number 3. Here we have a circle. And on this circle, we've got some points, and then specifically we'll have some arcs. So now we need to put the points on the circle such that when we draw out the angle, we have a 152.6 degree angle, which is going to be a pretty large obtuse angle. So, I mean, it doesn't have to be to scale, obviously, but like I drew mine something like this up here. Here's xy, okay, and here's z. So this, pretty large, whatever. This is 152.6 degrees. Okay. What is the sum of arcs xy, so this arc right here, and yz, this arc right here? Basically, what you have to do for this question is, first, you have to know that the measure of an arc is equal to double the measure of its corresponding inscribed angle. That means the measure of arc xz, so right here all the way around in orange, from here to here, okay? So the measure of arc xz is going to equal 2 times 152.6. An alternate way you could think about it is the measure of the angle, an inscribed angle, is half the measure of its arc, but we know the angle, we want to find the arc, that's why we double it and not half of it. Okay. So if you go ahead and do this, you should get 305.2 degrees. So that's the total measure of this orange arc. Therefore, the measure of these two other ones together is just going to be 360 minus that, or 360 minus 305.2. So that's just going to be 54.8. That's your answer you would fill in. There's no other work that you have to do for this. All right, let's look at the top of the next page, question number 4. Here you have a quadratic equation. It has technically two constants in it, P and W. And you're also told it has one real solution. They want to know, what is the value of W have to be? Okay, so if you're going to do this by hand, what you would basically do is, I would get this, you would have to get this equal to y. So that would mean py equals negative 4x squared plus 91 minus w. Then you got to divide everything by p. Since this is just one number, I'm just going to make one fraction. Okay, so now it's in the form of y equals. So again, to find a solution, that means that the y value is 0. So now you can use the discriminant. In other words, now you can do b squared minus 4ac. And because there's one real solution, you set that equal to 0. So in this quadratic now, a is negative 4 over p. B is technically 0. There's no x term. C is the 91 minus w over p. All right, so b squared is just 0 squared minus 4 times negative 4 over p times 91 minus w over p. And again, this whole thing is equal to 0 because there's one real solution. All right, the 0 squared just drops out. I'm going to multiply this negative 4 times negative 4 and make it positive 16 over p. Notice there's two p's on the bottom, which make p squared. So I'm going to multiply both sides by p squared. And technically, that means that p is irrelevant for this. Also, on the right side, notice you still get 0. So now we get 16 times 91 minus w. Technically, you could distribute this, but you actually don't have to. You can actually just cancel out the 16 and divide by that. And you still get 0. So now 91 equals w. So that's it. That's your answer. And you could go into Desmos just to confirm this. I'm going to type the equation. Okay, I'm going to set w equal to 91. Now, p technically will not matter, and I'll show you why. Because notice what's going to happen is when I slide this, notice it's just making it wider and narrower, or it flips it from opening up to opening down, but there's one solution the entire time. It's touching the x-axis at one single point, technically at the origin right here. So the p-value is irrelevant for this, okay? So this just confirms that the answer is w equals 91. All right, now, the way you could do the entire problem in Desmos is the following. You have to basically first take this quadratic. Again, you're going to have to get it in the form of y equals. So you're still going to have to do the initial work that I did using the other method. You're still going to have to do this first, okay? Then you're going to take the right side of it right here, and you're going to do regression, and you're going to do regression to its vertex form. And when you do that, well, I'll show you what we're going to do. So we got negative 4 over p x1 squared plus this. We could just make a giant fraction, 91 minus w over p. Okay, now we're going to do vertex form, which is x1 minus h quantity squared, but I'm not going to put a plus k because I want vertex form, but I want the k value, the y-coordinate of the vertex, to be 0. That will guarantee one solution. Now we have to add our element list for x. Okay, notice here, we are getting the correct value for W of 91. So this is how you could do the problem entirely in Desmos. Now, if you want to know more about this technique, in other words, about how to basically do regression of a quadratic to its vertex form for when there is and when to use that for when there's one real solution, or you can also technically use it for determining when there's two real solutions versus no real solutions, check out my ultimate Desmos guide to digital SAT math. I will put the thumbnail up on the screen for the specific video which covers this topic. All right, let's look next at number 5. Here we have a triangle question, equilateral triangle. Okay, they give you its height this time, and you're asked to find the perimeter. Previous problems, you've been given the perimeter and asked to find the height or find the radius of a circle where it's like inscribed inside a circle. So we know the height is 44. We also know, because it's equilateral to 60 is 60, and at the top it's 60, but it's split into 30 and 30. Okay, so we have 30, 60, 90 triangles. However, the 44 here is the long leg. It is the side across from the 60. Therefore, we are going to have to get the short leg, you technically take the 44 and you divide it by root 3. You do not multiply it, because we're not going short leg to long leg. We're going long leg 44 to short leg, whatever that, down here is. So when you do that, you then rationalize the denominator, 44 root 3 over 3. Then, of course, to get from the short leg to the hypotenuse, you multiply this by 2. So that becomes 88 root 3 over 3. So now to get the perimeter, of course, well, the sides are all the same. So it's just 88 root 3 times 3, because there's 3 sides. So the 3 in the denominators cancel out. Okay, so the perimeter is 88 root 3. That's equal to A root 3. All right, A must obviously equal 88. That's your answer. That's what you would fill in. Now, I'll show you an alternate method how you could do this in Desmos using basic trig if you do not know or do not remember the 30, 60, 90 special right triangle properties. Okay, so let me pick a different color here. You have a side, you have an angle, and this is actually shorter. You can actually go straight to the hypotenuse if you do this. Because basically I would say, all right, I have the side opposite the 60. I want to know the hypotenuse. So what relates opposite and hypotenuse? Well, SOHCAHTOA, it is sine. Sine 60 equals opposite 44 over hypotenuse. Well, that's x. You rearrange this, you get x equals 44 over sine 60. Okay, so now I'm going to go to Desmos. All right, instead of using x, I'm just going to use whatever, c for my hypotenuse. Okay, so c is equal to 44 divided by sine 60. Now, what I want to do is first, switch to degree mode so I get the actual correct value there. So the hypotenuse is approximately equal to this 50.80682. Okay, so that's the length of one side of the triangle. So now what I have to do is I have to take that and multiply it by 3. So right here I have the total perimeter of the triangle, okay? So in other words, the perimeter of the triangle is 152.47 blah blah blah, and that's equal to A root 3. So how can you find A? Well, notice you just divide this by square root 3, and that will give you the value of A. So if I just take this now and divide it by square root 3, there it is, 88. That's the perimeter of the triangle. That's an alternate approach using basic trig, not using any 30, 60, 90 triangle properties, and maybe you think it's quicker and faster, and you want to do it that way. That's fine. All right, let's look next at problem 6 here at the bottom of the page. So for this problem, we have a formula. We are solving this formula for y. All right, so to do this by hand, I would basically multiply by the common denominator, which is going to be 15 x, y, z. So for the first multiplication, x, z cancels out, I get 15y. For the second multiplication, 5 goes into 15 3 times, x, y cancels out, I get 3z. On the right side, x, y, z cancels out, I should just get 5. Let me just check my notes here. Yep. And then we can just subtract 3z on both sides, divide by 15. Final answer should be 5 minus 3z over 15. 5 minus 3z over 15. Correct answer for this one is going to be letter C. All right, so that's how you could do it by hand. Now, let's see how you could do it in Desmos. So, again, the way we solve formulas is type in, and it's kind of annoying, I'm going to use x1 and y1, but whatever, I'll do that. Not that big of a deal, just a little extra time. Type in the original equation, but do it as a regression statement. All right, all of these numbers are, let's see, supposed to be positive, which they are. Yeah, there's no negatives here. They're all also gigantic, which is kind of weird, but that's fine. We can still just check the answer choices. So I'm going to do first answer choice, 5 minus z over 15. All right. Does this, now I'm solving for y, so does this give me 6.16 times 10 to the 16th? No, it's a negative number and it's not 6.16, so that's wrong. All right, next. 5 plus 3z over 15. Does this give me 6.16 times 10 to the 16th? No, it gives me 2.109, so that's wrong. Next, change it to a minus. 5 minus 3z over 15. Okay, does this give me 6.16? No, it gives me negative 2.109 thing. So why is it not working out? Why is it not matching? It should give me the correct answer. We'll check D, which, I already know is incorrect. Oh, I realized no, it still should work. Anyways, let me check, z minus 5x1. Okay, D is obviously incorrect. It's not working. All right, let's double check. Why is C not working? All right, so let's do this. Let's try defining some values here just to get rid of these ridiculous numbers. So let's say x1 is 0.5. Let's say y1 is 0.2. Okay. So there we go. I picked some positive decimals for x1 and y1, and that gave me a much more realistic, easy numbers to work with. 0.5, 0.2, and basically z is 2/3. So now, all right, let's run through the answer choices just one more time. So 5 minus z over 15. Is this equal to 0.2? That's what I'm checking right here. y1 is 0.2. No. Let's make plus 3z. Okay, is this equal to 0.2? No. Let's make it minus. Is this equal to 0.2? Yes. Correct. This is the correct answer. It is letter C. So again, I guess the tip or the takeaway is, if it's giving you those like ridiculously large numbers in scientific notation, don't use those. Define your own values for as many of the things as you have to in order to make it choose reasonable, smaller numbers. So now let's go to the top of the next page, problem number 7. Here you have an inequality in terms of x, but there's also a constant in it. And it tells you what the solution set, what the solution to the inequality is, wants to know what the maximum value of the constant is. All right, so the way I'm going to start this off is just by trying to solve this for x. So subtract 12 on both sides, and then divide by 3. You get ax is less than or equal to 8. Now, technically, I would probably divide by a here, just because I want to compare. whoops, it doesn't flip yet. It's x is still less than or equal to 8 over a. Okay, so now I want to compare this to the solution set. So basically when you're looking at both of these, really what I'm thinking about, what I'm trying to figure out is, okay, what is the value of a that I can plug in here to make these two inequalities equal to each other? So first of all, notice it has to be a negative value because we need to flip the inequality sign. And second of all, it has to also turn the overall number on the right into a negative. Currently, it would be a positive. You know, it's positive 8 divided by a. So a is just going to equal negative 1 because if you replace it with that, x is less than 8 over negative 1, and technically you're dividing by negative 1 here in the previous step. That's what causes the inequality sign to flip. 8 divided by negative 1 is negative 8. Now this matches the given solution set. So the correct answer is going to be negative 1. So now let's go to Desmos and let's look at basically, first of all, how we can check this, or really it's how you could solve this using Desmos entirely. So essentially, what I'm going to do is type in the first inequality, and then I'm going to type in the solution set. And then I'm just going to add a slider for a, and what I want to have happen is, basically, I want these two to be overlapping entirely. So notice when I go to the positives, right, they are not overlapping entirely. One's going to the left, one's going to the right, and that's not what I want. So, but now notice what happens is when I flip this to the negatives, notice now they're both going the same direction. This is what I want. I want to find the value of a such that the solution to the top identically matches the solution to the bottom. And, you know, you go over here and notice right here at a equals negative 1, they overlap completely. They are identical. The solution set to the top inequality is the same as the solution set graphed out, you know, the bottom, the blue inequality. Now, the only potential issue with this approach is like maybe it works out such that a is a decimal, in which case it might take some time to try to narrow down exactly what that decimal is. So that's one thing to keep in mind. This might not be the quickest or fastest approach, but at the very least, you still can use this to check your answer. You know, if you solve it out by hand and you get a equals negative 1, again, circle this because this is what you would type in, you can, at a minimum, still go to Desmos, type everything in, and just confirm that, yes, that is the correct answer to this problem. Okay, let's now take a look at question number 8. Here we have another right triangle problem. So go ahead, I'll draw the right triangle. Angle B down here is the right angle. I'll put A at the top, C at the bottom. AC, which is the hypotenuse, is 70. Okay, we know tan A is equal to 3 over 4. So opposite, here's angle A up here. Opposite, say 3, and adjacent would be 4. Tangent opposite over adjacent. However, the actual side lengths in this triangle are not 3 and 4, because then it would not meet the criteria that in a triangle, the sum of any two sides is greater than the length of the third side. 3 plus 4 is 7. 7 is not greater than 70. Okay, so instead what I'm going to do is make these 3x and 4x, okay? We know that the ratio of these two sides is 3 to 4. We're going to figure out the exact values of them. So I can set up Pythagorean theorem, a squared plus b squared equals c squared. And now I'm just going to go to Desmos and solve this problem using regression in Desmos rather than doing it by hand. Now, because I'm using regression, I will have to type x1. Okay, so the value for x, or in the regression statement x1, comes out to be 14. All right, so that means 3 times 14 is 42. 4 times 14, you don't need this for the problem, but it's 56. So what is the length of BC? It is 42. That's what you would type in. That is your final answer. Now, alternate ways you could solve this. One way, which is actually quicker, would be to notice that um, this triangle, if like, okay, with angle A having a tangent of 3 over 4, that technically means that this triangle is a 3, 4, 5 right triangle. And if you recognize that, then you can say, oh, well, 5 times what is equal to 70? Or you could just go to Desmos and do 70 divided by 5. But you can see basically the scale factor would be 14. So then you would just do, oh, 3 times 14 is 42. This is the length of BC. Again, it's a little bit quicker way than, say, using Pythagorean theorem or recognizing that you technically have to label the sides as like 3 times x and 4 times x to actually solve out the equation. So that's a second alternate approach. A third approach you could actually use is to use basic trig, find the measure of angle A, and then use that value to calculate the measure of BC. So if you want to do that, here's how that would work. Okay, we know A is just going to be inverse tan of 3 over 4. So I'm going to go to Desmos, delete this. Okay, now notice it's not giving me an angle in degrees because I have to switch to degree mode. So click the wrench up here, make sure degrees is selected. All right, so that's the measure of angle A. I'm going to define this as A because I'm going to use it later. So now that we have that, now I can set up a, so let me just erase this temporarily. Now I can set up a trig ratio where this was, is it 36.7? 36.8. Okay, so this is just 36.8. This I'm solving for is x, and I have the hypotenuse here as 70. So I want to find the opposite. I know the hypotenuse, therefore I'm going to use sine. So in other words, sine of A equals opposite x over hypotenuse 70. And if you want to solve this for x, you just multiply by 70. Therefore, BC should equal 70 times the sine of A. So 70 times sine A. And notice I get the exact value of 42. That's because I defined the measure of angle A using this letter so that it carried down the full exact value with all the decimal places to the next to this next row for the calculation. Okay, I do not round it, I do not approximate it, I carry down the exact value, and that gives me exactly 42, which is the correct answer. So that's an alternate way you could solve this one as well. All right, now let's take a look at problem number 9. Here we have a problem where you're given a histogram for basically some number of points scored by a player during, whatever, 25 different basketball games. Okay, you're given the mean value of this data set here. Then you're told that you form a new data set or a different one by removing one single value from this. So you remove a single value of 17, and they want to know which of the following must change from B compared to A. All right, so a couple things. The mean of data set A is 16.72. All right, that's given to you. If you take away a value of 17 from data set A, the mean, by definition, will change. The only way that the mean would not change is if the value you were taking away was equal to the mean itself. But if you have a bunch of items and you remove an item, the mean will guaranteed change unless the item you're removing is the same as the mean or average value. So for starters, the mean of B will be different than the mean of A, i.e. it will change. So we know the answers could possibly be this, not this, and it's technically not going to be this either. Now, the question is, does the median value change? So, okay, you think about 25 values, right? The median value will be the 13th value. It's basically going to be like values 1 through 12. 13 is directly in the middle, and then there's going to be 12 values on the other side, which is technically 14 through 25. So if you count this up, right, we have 2, and then we have 5 here, which means like cumulatively we're at 7, and then you add another, so this is 5, another 6 here. So cumulatively, you're at 13. So the 13th value is somewhere in this bar right here. Something from 14 to probably 17. All right? So the median is somewhere in there. The problem is we don't know exactly how the scores are distributed within the bars, okay? Because these are ranges. These are not specific individual single values. So it's impossible to tell what happens to the median because, first of all, we don't even know the median of the original data set. We know the range that it's in. We know it's between 14 and 17. We know it's somewhere from here to here, but we don't know what the exact value is. So we can't even determine that, which means we can't tell if it's going to change for B once you take out a 17. So the correct answer to this one, at least as I've worded it, is going to be answer A. The mean is the only thing that we know for sure will change. All right, let's look at the last question. This is problem number 10. This lovely diagram came to us from a person who recreated it and posted it on Reddit. So in the circle, we have point O is the center. You're told BD here is a diameter. It goes through the center. That would make sense. And you're also given that AC and BC are the same. So this is an isosceles triangle. So I don't know, like this side and this side are identical. The full side, not just, the part to the left of where it intersects BD, the full thing. Okay. Find the measure of DBA, which is this angle up here. So we know that first of all, we know this angle is 71, and we know this angle right here is also 71 because it's an isosceles triangle, and you're told AC and BC are congruent or have the same length. So angles opposite congruent sides will have congruent measures. All right. Now, next thing we can figure out is that this is angle BAC right here is an inscribed angle. Its measure is equal to half the measure of its intercepted arc, which is arc BC right here. Another way to think about that is that the measure of arc BC is equal to double the measure of angle BAC, which is 71 degrees. So 2 times 71 is just equal to 142. So this arc has a measure of 142 degrees around the circle. Now, because BD is a diameter, that means that, from B all the way down to D, that entire arc is 180 degrees. Okay, so from here all the way up to here, 180 degrees. Therefore, DC, just pick a different color, right here, this arc will just have a measure equal to 180 minus 142. So that's going to be 38 degrees. So this is going to be 38. Therefore, angle DBC, which is another inscribed angle, is equal to half the measure of its corresponding arc, which is 38. So, and let's pick a different color, this angle right here, just the orange part, is going to be equal to half of 38, which is 19. Now, a lot of people on this question reported that their answer was 19. So that would seem to indicate that they wanted you to find the measure of angle DBC. But someone else in the comments said you were asked to find the measure of DBA. So I'm solving it as if you're finding the measure of angle DBA. But if you really were finding DBC, then you would be done. The answer would be 19. Okay. Now for DBA, there's one more step. You technically just have to do 71, measure of angle B, the whole thing, minus 19, the DBC, the small orange part. So 71 minus 19, that would give you 52 degrees. Okay, just for the blue part right here, 52. All right, so I hope you enjoyed this second October 2025 SAT Math official test problem worksheet and video. If you did, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Just a reminder again, there's a link to the PDF file in both the description of the video and the pinned comment below. If you have questions or comments or alternate solution methods to any of these problems, please leave them in the comments below, and respond to them, take a look at them, possibly put together an alternate solution video for some of these October problems. Also, if you haven't done so already, check out worksheet and video number 1. And once it is posted, worksheet and video number 3, which again is going to be the repeat problems, problems that I either solved multiple times already, or have come up just recently. For example, maybe I just solved them on the September one of the September videos. And of course, the last thing, if you're looking to improve your knowledge of Desmos, please check out my Ultimate Desmos Guide to Digital SAT Math. It is over 5.5 hours of tips and tricks and 65 practice problems to help you ace the digital SAT math section by using Desmos.